Hey guys, welcome back to the shop. Today's episode we have a 2002 CR250R cylinder. Unfortunately, the engine kind of took a dump. The rod lost it lost the lower rod bearing, and the pieces of the rod bearing came up through the piston. Um, didn't tear the piston up as bad as it could have. However, there's some pretty deep gouges in the cylinder where some of the debris got up in here. So the electrofusion is junk, and we either need to replate it back or we need to take another approach. If you watch my channel at all, you'll know that it isn't very often that we leave a 250cc motor at 250cc's. Did some checking around. There's a couple of kits out there to make them into 270s, which really isn't that much bigger. Don't get me wrong, 270 is better than 250, but we really want this thing at 300 cc's or just slightly above if we can get it there. So we're going to have to go build some custom parts for this one. In order to get it to the displacement that we'd like to have it, we're going to go ahead and have to make a custom sleeve. This is a blank flanged LA sleeve, cylinder sleeve. Nobody makes a cylinder sleeve to do this large of a bore in the CR250 cylinder, so we're going to go ahead and make this from scratch. Along with that, we're going to go ahead and install this custom made Wiseco big bore piston kit. It's a piston that's made for the forging is made for something else. There's some minor machine changes that we had to make to the piston in order to fit it properly into this cylinder. But we're going to go ahead and strip this cylinder down, get the power valves out of it, get all these studs off of it, and we're going to get it punched out so that it matches the cylinder. Actually, so it's slightly undersized. You'll see later on in the video. We'll freeze the liner, we'll heat the cylinder up, the cylinder will grow, the liner will shrink. That'll give us enough room to get the liner in there, and it'll be permanent once we get that shrink fit in there. And then we'll go ahead and bore it out to fit the Wiseco piston, and then we'll port it back to the specs that we want. So let's get the cylinder stripped down. Okay, got it all stripped down now. You can see power valves are pretty gungy. It needed to be serviced in any case, but we'll go ahead and put it on the boring bar now and start making some chips and make that hole big enough to get the sleeve in. I have the cylinder mounted in the boring fixture. You can see the boring bars on it. I made one initial pass. I put the cylinder in the boring bar, or in the fixture. I center the boring bar on the original bore, and then I run it up and down with the dial indicator to make sure that I'm true and square. I did lightly scuff the top of the cylinder on a granite plate with some emery cloth before I put it on there, just to make sure it was good and flat, and make sure the bore is going to be good and square to the gasket surface. When we get done with this, we do a final cut to make sure that top and bottom surfaces are exactly perpendicular to the bore, but we want to make sure that everything's set up as close as possible when we start. This was a Nickel plated cylinder originally, or before we started on this big bore kit. Nickel is extremely hard, so I do have to use a carbide insert tool on this boring bar. To bore aluminum, I don't actually need the carbide insert. I do have some inserts that are made for machining aluminum, and I'll go ahead and use those for the rest of the machine operation. We're going to go ahead and set the bit now. We'll take 40 thousandths or 1 millimeter per pad, and we'll mic it and do our final cuts. There we have it. First pass through the bore, 1 millimeter bigger than it was. We'll go ahead and crank it back up, reset the bit, do that about 6 more times. The cylinder is now bored to the final size. It is 4/1000 of an inch smaller than the steel sleeve that goes inside of it. It's technically not a steel sleeve, it's a cast iron sleeve, but we want the sleeve about 3 to 4 thousandths bigger than the bore in the aluminum, so that will give us our press fit, our interference fit when we put it together, so we have good heat transfer and the sleeve stays put. So the next thing we need to do is cut the shoulder for the flange in the top of the sleeve. When you re-sleeve a two-stroke, you almost always do it with a flange either at the top or at the bottom. This one happens to be a flange at the top, so we need to make a step in the top. So I'm going to go ahead and move the cutter out to the diameter of the step, and then I'm going to hand feed it down 200 thousandths, which is the thickness of the flange. There we have it. Now we have a notch cut in the top for our flange to nest into, and we're ready to pull the cylinder out of the jig and clean it up. We have the cylinder all bored out. You can see that not only is it bored for the right diameter for the sleeve, but we've cut the flange relief. You can see we cut right to the very edge of where the flanges are going to be for the cylinder studs when they screw in. It's measured out so that the liner almost touches that edge, but not quite. We have a little bit of clearance there. That's going to give us the most amount of flange edge that we can have here, so that we have good head gasket sealing and we have room to cut our O-ring groove. So the next thing to do is take this blank sleeve and mark it all out and cut some ports. I've got the sleeve all marked out with a porting pattern that I want in it, and it's chucked up in the rotary table in the milling machine, and we'll go ahead and cut all the ports with a mill. Okay, we have the sleeve installed in the cylinder now. Went ahead and cryo fit it in. You can kind of see, I don't know how well you can see the port match down there. Let's see if we can get you down there. It's a pretty good port match because we measured everything out ahead of time. Um, the intake, I've left a lot of room on the intake at the boost port as well as the width because I need to make sure that my ring ends are going to pick up a sleeve area and not end up hanging out in the port. And I want to make sure that my width is wide enough to get good power, but not too wide that the piston wants to drop into the hole. So you can see there's a fair amount of work to do here to line that up. There's a little bit of port work to do all the way around just to make sure everything's blended perfectly. Do that intake, and then we're going to fit the power valve. So it's time to go off to the porting bench and get some grinding done. The port heights are all set in milling machine because they're dimensionally critical, but they have to be hand blended to the individual castings. And when we're doing a big bore kit, there's more deviation in between where the casting is and where we want it to be. So we go back in and blend all the ports. We also do the bottom of the liner where the transfers come out of the case into the cylinder itself. So you can take a look at the transfers, the exhaust, and the intake as well as the bottom of the liner. The power valve is often the hardest part or the most technical part on doing a lot of these big bore kits, simply because the outside of the liner moves into the area where it's machined for the power valve. So we have to do a fair amount of delicate machining in the power valve area to get them to actuate. But when we're done, we have a fully functioning power valve. Once we have the liner in, the ports matched, we'll hone the cylinder sleeve to approximately a thousandths under size, and then we will go ahead and machine the head gasket surface. We do that in this mandrel in the lathe. We'll go make typically two passes. We'll make a very light skim pass just to see where it is, and we'll come back and make somewhere between a 2 and a 5,000th finish cut. Make sure that the head gasket surface is perfectly smooth and that it's perpendicular to the cylinder bore. So you'll see us make a couple of passes here, and you'll see what the finish looks like. The last thing we need to do is machine the head. I have a separate video on how we go about machining the heads for big bore kits on 250Rs. So if you want to see that, go ahead and go look for the other video on doing a big bore head on a 250R Honda. But basically, we remachine the squish, we remachine the bowl, and then we CC the head to make sure that we have the right compression ratio for what type of fuel and what riding environment the customer is going to use. All right, this is the cylinder and the head reinstalled back on the bottom end. The motor did require a full rebuild, so everything down in the bottom end is all rebuilt. Cylinder's on, the squish has been checked, compression's checked, reed valve is back on. So it's about ready to go on the dyno and put a little bit of time on it. So if you enjoyed this video, appreciate it if you'd subscribe and like the video. As always, thank you for watching. Goodbye.